welcome to the demo part of the interpolation lecture. So what I have over here is the data that I'm going to add to this video includes a database. So if you can take a look at it, it includes a database called Africa Health Data. So once you make a data connection to that folder, you are going to see that it has 4 layers in there. And what I'm using for this demo, which I wanted to use first, is the Uganda boundary and then the Uganda malaria incident. So these are incidents of malaria that happen within Uganda. And what we are going to see is if you add the data to ArcMap, you can see that they did a sampling of the malaria cases, within the boundary of Uganda, but it's not everywhere. And what we are going to use is we are going to use the method of interpolation to see if we can predict the possible malaria outbreaks in those areas that they did not do any sampling. Okay, so if we take a look at the incident data, open the attribute table, you can see. Let me open this guy up. Come on, there we go. You can see that the data has the incidents. So each point that you have actually has a set of incidents that was recorded over there. So this could be other villages that they were sampling or little towns they were sampling. But each of them has the incidents, which we call the population. So for each of those sampling locations, these are the population of incidents that they recorded at that location. Okay, so let me dog this guy down here. We'll come to it when we need it. All right, so in the first steps in doing this exercise, the exercise also comes with the documents also comes with a Word document, and that Word document pretty much will walk you through everything that I'm going to do. You can see there's a Word document in there, so that is going to walk you through that process as well. But the first thing I would like you to do, because we are going to work in spatial analysis, is to ensure that the extension is actually there. So go to Customize, Extensions, and then ensure that you have spatial analysis checked on, and then click on OK or close on that. And then the next thing we want is we want our toolbox. So make sure you launch your toolbox so you can use the spatial analysis tools in there. So here you can see my tools are set. All right, now the first thing the data wants you to do is it wants you to open up the IDW2. So here we are going to use the IDW2. So we are going to come under spatial analysis tools, and then we are going to go through to interpolation, and then the interpolation you're going to see the IDW2 is here. So double click on that too, and then the input data is going to be our incidents. Our value field is going to be your incidents. So this is going to choose that to be your population, and then the output, you can let the output go into the database that you are going to have, and then it tells you the size that you want. So here, make sure I'm doing the demo on my laptop. I don't want to mess up the data I'm going to send to you guys. So here you need to make sure that you browse and then you send the data to the right location. So you need to make sure that you are sending the data to the right location on your drive, which will be the data folder, the African data, and that database. So you want to make sure that you are sending the data over there. All right, now the instruction tells you that we want the output cell size to be 1000, and that means we are creating a grid of what, 1000 by 1000. All right, and then the next thing we want to do is, actually there's one thing that we need to check first. All right, let's cancel this for a minute. Here, let's open the population data. You can see that data is projected, so that is good. The next one, here we go. So here we're going to be in trouble. See, the Uganda data was not projected, so that's why I'm looking over here and I'm seeing decimal degrees. So what I will actually want you to do is, let's close this guy and then I'm going to open a new ArcMap. Let me open a new ArcMap. And then I want to add in the incident data first, because I know the incident data is projected. So I'm going to add the incident data first before I add in the boundary, and then I'll project the boundary data. So my data that I'm using for my analysis are both projected. So here, let me add the data back again. So I'm going to add the Uganda incident data first, because when I do that, you can see that my coordinate system is projected, because ArcMap is going to always and always use the coordinate system of the layer to define that of the data frame. So now I can add in the boundary, and now I can right click on the boundary, go to data, export, and then I'm going to export using the data frame, so it will be projected to the same one as the incident. And then I'm going to send it over here to I'm going to my default boundary database. So I can say Uganda boundary PND underscore project, save. Okay on that. Yes, I want to add that, and then I can remove this guy. All right, so now that that is done, now let me save my work. I want to save it as that. Yes, override the old one. And now let me ensure that my extension is still out there. So my extension is there, good. So now I can go to spatial analysis. I can go to interpolation, IDW, add in my malaria incidents. My Z value here is going to be the incidents. My output is going to be that. And then I'm going to change this guy to say 1000. So here, because the data is in meters, it's going to be 1000 meters by 1000 meters to create that cell, and then keep everything default, and then click on run, and then see how it's going to run and give you the results of that. So whilst this is running, what you can always see is now, so the data is done. So here, let's change the output of this guy, make it hello. All right, so now we can see. Now, if you remember your experience from the previous the hotspot that we did, we could have set up the boundary so that this guy will all clip to that. So since we've learned that already, let's go ahead and rerun this and fix that. So double click on the IDW again. Input is going to be Uganda. It's going to be that. Let's call this, change this guy to 1000. And remember, for us to change all those parameters, we go to environment. So go on environment, and then we wanted the processing extent to be the same as that of the boundary. And then also we wanted if you go to analysis, you want the max, you want it to match it to the boundary. Okay, and then what else again do we need over here? Those are all we need. And now when we hit on OK on this, and then we run it, when it's done, everything should fit within the boundary, so we don't have anything overlay. Here you go. So because we've already learned the previous one, this method, this is what I would like us to use. So here, let's change the symbology. Double click on that. Let's go to symbology. And then I like using so here, the values that you're getting over here, the colors will tell you the cases. So it's predicting that between the greens are between 1 and 5 cases, and then as the color changes, it goes between that. Obviously, if you don't like that color, you can use a more brighter color, and then here I can reverse, so flip it, and then do it this way. So Where I have red means where I have more cases. Pretty much that's what it's showing. So it's anything from 40 to 41. And how we can check this to see is we can check a value. So click on your identifier and then click on the point, the sample point that we know. We don't want that. We don't want the topmost visible layers. And then click on that. Here we can find, let's do this. So we have the boundary, we have that, we have the incident. So here you can see this is 45, number of 45. So here it's giving us the red is between 40 and 44.99. And if we check on the known one is 45. So it gives you an idea. And then obviously as we click around, it will tell us, so here I want this value. You can see this is 37. So as I click around, the software is going to tell me roughly what the cell value is in that area as we click around. So the further I go away, the lower the value becomes, right? Because I'm moving away from the sample location. So that is how your IDW interpret the surface for you. So if they are going to plan to slow down the malaria outbreak, this gives them a good area of villages that they need to pay attention to, because the value that is occurring over here is so high that it's likelihood that it's going to be high close to that infected area is also going to be high. And that is how we use the IDW to make those kind of investigations and decisions. Okay, so that's the first part of the assignment in the Word document. The next part it wants you to do is to use the natural neighbor to do the same interpretation. So here, the natural neighbor is this guy over here. So the same thing. Now let's run this one, and we are going to compare the results. Pretty much that's what we're doing. And our input is going to be the incident case. Our Z value is going to be the incident. Give it the output. And also here, we want the output to be, the cell output size to be 1000. And remember, because we have learned the environments, we'll go back into environment, processing extent, we'll change that to be the projected boundary layer, and then we'll go to the raster analysis, and then we are going to say that we want you to be the same as, no, the same as the boundary. Hit on OK on that, and now let's run that. Now you can see that it uses a different method. That method does not stretch to the ends of the data, unlike the IDW. So here, this is also giving us some values to see. Okay, so here let's change the symbology again to something that we can easily. So I'm going that, and then I'm going to flip the colors. So move from the smaller to the highest. And now look at that. That one is giving us a little. So here, showing us where we have a pattern of red, and then the pattern of red stays in the middle, and that is absolutely different surface than the one we got. So if you take a look at that, you can see that that is a little different. The method that he uses for its interpretation is not a little, is different from what we do with the IDW. Okay, so here the next step in the example shows us how to check the accuracy of our interpretation. So we are now getting values of areas that we know are based on the interpretation. Now the software, the exercise wants us to verify the accuracy of those. So what it wants us to do is it wants us to turn on the layers, turn off all layers with the exception of the incident data. Okay, so here and then we are going to open the attribute table, and then what it wants you to look for is identify object with object ID, object underscore ID equals to 53. So just scroll down and see number 53. So object and object ID underscore 1, and then select it. So when it selects that, you can see that that point is selected. And here what we are trying to do is, here we know that the incident value at that location is what, 40. Okay, so what we want to do is we want to do an experiment without including this number 40 and see if we are going to get any number closer than that. All right, so once we have this selected, we are going to now switch selection. So we are going to go in and say switch selection. So click on your switch selection. So now you can see everything else is selected with the exception of that particular one that we want. Okay, the 53. So you can see over here 93 of 94 selected. All right, good. So now we are going to run the IDW again. Now remember, because ArcMap is always going to give preference to data that is selected, this method means that everything is going to be used with the exception of this point. So let's use the IDW input that z value is ID, put the output face, change that to say 1000. Let's go to the environment. Let's change the processing extent to be the same as the projected boundary, and then our raster analysis, we wanted to max that to the boundary as well. Okay on that, and now let's run it. So ArcMap is going to use only the values that are highlighted to do. So now that we know the answer, we can check to see this value. This is the one that we selected. This is 53. That's the one that we selected. Right now we have let's change the symbology of this as well. Let's switch it back to the red to green, and flip the colors. So this area is supposed to be a value of 40. So now if I click on that area, you can see it's going to give me a value of 27.8. So as you click around, you can see the number is going to vary. So that area is 30, right? And that was 40. So the measured value is 40, and now we are getting ranges from 27 to around 30. And as you move around, now the difference is using the point from here all the way here, all the way here to calculate this value, and the ones down here. But this is 27 is, is good enough, showing that the value of potential cases over here is going to be high. All right, so we can see how close we are with a measured reality to what it was detecting. And in this area close to the same point, it's at 30. It's at 30 30 cases. So you can see how good our prediction is, or how far off we are. So right here it's at 27. When I click over here, it's 27. When I click over here, it's 30. It's 30. So you can see we are about 10 to 13 points off from the measured value. And that is how interpretation is supposed to help us to visualize this data. Okay, so that is what I want you guys to do. I want you guys to use this data to perform the same analysis using the both, and then when you are done, what I would like you guys to do is use the same data and perform an analysis on the Cameroon one for the Ebola to do a surface for the Ebola case. Okay, so this is what I want you guys to do. And then when you are done, obviously take a screenshot of that and then send your screenshot over to me, and then we'll go from there. But other than that, I would like to see you practice this. This is how we do this sort of analysis, and we get the results that we need. The third part, the final step of it, is how to visualize this in 3D. If you want to take a look at it, that in ArcScene, the steps are in the in the Word document. But if not, I will add that later on for you to see how we can visualize this hotspot in 3D. So on that, practice this, and I want this submitted by tonight, so I can assure that yes, if we were to meet in class, we would have gotten this taken care of. So I'll upload this video right now and the data as well, and I expect you to submit it by end of tonight, so I can be sure that we are coming along in our journey. All right, thank you guys.